So today I'll be briefly discussing fluid distribution functions that are a key part of fluid dynamics. Okay, so we'll be talking about FDF in CFD, and the first function, most are to do with introduction of a fluid in another fluid system. So fluid plus fluid system is interaction. And the first one you need to understand is diffusion. Very simple. It's governed by the three kinds of it: facilitated diffusion, passive diffusion, osmosis, reverse osmosis, and then there is governed by a fixed law of diffusion. Then you've got effusion, Graham's law of diffusion, Graham's law of effusion, and then you've got the infusion. Now that's not the T infusion, although the idea is similar. And then you've got perfusion. That's capillaric. It happens at capillary level. Okay, so fluid dynamics functions. In CFD, you add a fluid into a fluid system and then you observe the interaction, and these are the four kinds of interactions we come up with: diffusion, effusion, infusion, perfusion. The first one is diffusion. Down the concentration gradient, down the concentration gradient, or you could also write it as, and it's passive, no ATP required, and it's periodic. Now, effusion is something popping out, like for example, if there's a puncture in the artery or vesicle, when a tire punctures, if you've got a boundary and the boundary conditions are breached, and then or it's a wound, so breach of boundary conditions. So it's a breach of boundary conditions, and it could be injury, damage, and the likes, and it can be a physical system or a biological system. Infusion is to do with clinical pharmaceutics, with nursing calculations. It's injections of all sorts, muscular, intravenous, and injections. It's the idea of injecting stuff. And perfusion is a little bit difficult because perfusion is rarer, but it's, if I may say so, it's the idea of endocrine pathways. Like the best example would be hormonal systems, how the exocrine and endocrine organs squirt out the hormones, and then those hormones perfuse themselves through the circulatory system, attaching to different receptors on cells, and taking it from there. So in fluid distribution, we are studying fluid FDF in CFD, fluid distribution functions in computation fluid dynamics, where we understand the behavior and behavioral interaction of when a fluid is introduced into an already existing fluid system. It could be a gas or a liquid. First one is with diffusion down the concentration gradient. It's passive and periodic and stops equilibrium. The net The second one is effusion, breach of boundary conditions, injury or damage, and then infusion is injections. The best example would be injection, the most simplistic example, and perfusion would be endocrine pathways and, capillary action. Now, it's not the capillary action of chemistry. I'm using the word action to talk about capillary perfusion in the human body as well as capillary action. So these are the four conditions. I want you to take a screenshot of it, and I think it'll be far better if you take a screenshot from here. It's just at my chest height. So yeah, go ahead. 5, 4, 3, 2, 1. Thank you. And so I hope you understand this small, difference between diffusion, effusion, infusion, perfusion. And diffusion has its three types: facilitated, passive, and facilitated, and they're governed by fixed law. Graham's law of diffusion, Graham's law of effusion. Infusion is separate. It's for gases and liquids. It's quite a prevalent phenomena in clinical physiology. And perfusion is all about, it's very slow. It's a lot slower. It's a lot slower. So it's very, very slow. It's very slow. So yeah, that's how things are. Very slow. So yeah, I hope you've learned something today, and I'll take it from here. Thank you.